Welcome again. This is Stephen from Kenya, continuing with our basic mathematics lessons. We have just seen the definition of mathematics and how to perform the three stages involved in performing arithmetic operations. Let's now look at the counting system, our number system. Our number system which we use is called the natural number system. I believe the reason why it is so is because the human being has got 10 fingers and we are used to counting in tens. So the natural numbers are all natural numbers are all positive whole numbers including zero. We can also call them the counting numbers. They are also called the counting numbers. The counting numbers. Another word we can use for them, which is also good, we can call it, we can also say natural numbers, the system, the natural number system can also be called the decimal system. Can also be called the base 10 system. Base 10 system of counting, because we are counting in tens. Why? Because we are counting in tens. So we want to give a general rule. To help us in all the number systems. We can say that if a counting system, or if a number system is base n, if a number system is base n, that means we are counting in n's. Then there are n digits including zero, and the counting always ends in 10, and the counting always ends in 10, always ends in 10. So let's use that definition to have a look at our natural number system. We can therefore say that counting, let's take example. For example, base 10. Base 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have, that's where we reach. Let's see how many digits we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 digits because we are counting in base 10, and the counting will end in 10. So we reach 1 0, and 1 0 are repeated digits. So that's how we count in base 10. We start from 0 and we end with 1 0. And all together we have 10 different digits including 0. So we would like to say that, for example, if you are counting in base 2, you'll have 2 digits including 0. So you'll count 1, 0, 1, 10. That's how you count in base 2. That's just an example. Now, so we have seen that in natural numbers we have 10 digits, and these digits keep on being repeated. Once you reach 10, you start again with 11, 12, 13, 14, and so on and so forth. You keep on repeating the same digits. So that's one property. Let's take a hypothetical number, or just an example of a number, and we see the place value of a number. Now, let's take a number like 4, 7. So we want to talk about place value of the digits in a number. Place value of digits in a number. So you have a given number and you want to look at the place value of digits in a number. So a number can have, remember that a number can have 1 or more digits. A number can have 1 or more digits. So if we take a number like 47, let's take a number like 47, 3, 6, 25, 9, 8. It's a big number. 5, 64, 7, 31, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we say 0.7, 8, 9. Now we want to know what is the place value of a number, of each digit. Place value of the digits of this number and the total sum of the digits. What does this number represent? What is the value of this number? It's a very important question. And the simple way to look at it is to say that here is, we can say that since we are counting in tens, this place is 10 to the power of 0. The ones, this one is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power of 9, 10 to the power of 10, 10 to the power of 11, 10 to the power of 11, 10 to the power of 12, and 10 to the power of 13. On this side we can say 10 to the power of minus 1, 10 to the power of minus 2, and 10 to the power of minus 3. I would like to explain a little bit of why we say 10 to the power of something. For example, we know that if you take 10 times 10 is equals to 100. Now, 10 means you have multiplied 10 one time. And therefore we can say 10 to the power of 1. So we can simply say that since we are multiplying, we have 110 and another 110, we can say that 10 to the power of 1 times 10 to the power of 1 will give us 10 to the power of 2. We have added the powers, and we can see the 2 represents the number of zeros. So 10 to the power of 2 represents 100. 10 to the power of 1 represents 10. If you divide 10 divided by 10, if you have 10 people and you divide with 10, you should get 1. And we can use that in terms of powers. We can say that 10 to the power of 1 divided by 10 to the power of 1 will give us 10 to the power of 1 minus 1, so it's 10 to the power of 0. So any number raised to the power of 0 is 1. So any number raised to the power, any number to the power of 0 to the power of 0 is 1. That is to say, i.e., n to the power of 0 is always 1. Now remember that these numbers are all in base 10. So here we are talking of base 10. We can apply the same rule to base 2. And this is very good for us to understand. So when we say that 10 to the power of 0, we are saying ones. And therefore here the place value is 1. 10 to the power of 1 is 10. And the place value of this position is 10. So here we have got 3 tens, 30. Here we have got 1 ones, 1. Here we have got